Good evening, everyone. Welcome to NYU Abu Dhabi. For those of you who are here for the first time, enjoy the facilities tonight. My name is John Burt. I'm an associate professor of biology here at NYU Abu Dhabi, where I've been based since 2009, so before we even had this campus. The reason that I work here is as a marine biologist. This is one of the most amazing marine ecosystems that you can work in the world. We have very extreme temperatures, as many of you are probably aware, in the summertime. You know, if you go down to Saadiyat Beach here and you go for a swim, you're swimming in seawater that's 36 or 37 degrees Celsius. And most tropical organisms, of course, cannot survive those temperatures. Many marine species will start to go south at around 31 or 32 degrees Celsius. And so we're sitting comfortably a number of degrees above that with organisms that have adapted to these issues. But of course, we as a species are having monumental changes to the geochemistry of the atmosphere of our planet, and as a result, we're seeing increasing warming of these seas that are already extreme here. So I'm really interested in hearing tonight about a group of organisms that I don't work on. So our lab specialty is coral reefs. We also do some work on mangroves. And right now, for yesterday, today, and tomorrow, we're actually hosting a workshop that's focused on the coral reefs of Arabia, in particular the Arabian Gulf and the Sea of Oman and Arabian Sea, and looking at the changes that have been happening to those ecosystems over the last number of decades and potentially continuing into the future, and trying to better understand those changes so that we can better inform management and policy to try and preserve these amazing ecosystems. Because these ecosystems, not only in terms of being very biodiverse and supporting economic sectors like fisheries, are also, of course, home to the amazing organisms that we're going to hear about from our speaker tonight, the hawksbill turtles. Just as some background for you, Dr. Hind Ameri is joining us from the Environment Agency of Abu Dhabi, where you can see that she's a marine conservation scientist, her specialty obviously focusing on turtles. And she's been there for almost a decade now, since 2014, so showing an impressive track record of using research to try and inform management within the institution that she's worked in here in Abu Dhabi. She has her PhD from Exeter University in the UK, which was under Brendan Gottlieb, who's actually Exeter, I just learned recently, is connecting with the UAE and starting a field-based program here on the east coast of the Emirates in, let's say, the coming year or so. She has an MSc as well from Leeds University, where she works with a good friend of mine, Maria Beggar, and her MSc was focused on biodiversity and conservation. And she did her undergraduate degree here in Abu Dhabi at Abu Dhabi University in environmental sciences. For those of you who are interested in the environment writ large, turtles, coral reefs, seagrass ecosystems, as well as the amazing terrestrial ecosystems we have here on Earth, I'm the lead editor of a book that's coming up from Springer Nature that's going to be released in about probably 3 or 4 months in advance of COP. That's about 550 pages long, that is titled A Natural History of the Emirates. We're also providing this book completely free of charge as an online format. So you can buy the physical book if you want. Most people don't read physical books anymore. If you read PDFs or Kindles or whatever, it'll be available for download at no cost in English as well as in Arabic. So look forward to enjoying that in the future. And I will now hand it over to our amazing speaker for tonight, Hind Ameri.
Thank you, John, for that very humbling introduction. And seeing you and hearing you say that I'm almost completing a decade at the Environment Agency just made me feel how much I spent time at the Environment Agency. Assalamu alaikum and good evening to every one of you. Thank you all for being here today. It gives me great pleasure to be talking to you about something that I am very passionate about, and I hope towards the end of today I can instill maybe a fraction of that passion in each of your hearts. So I was approached once and was asked, what if? What if sea turtles no longer existed? What if our oceans no longer had sea turtles? And in other words, they actually said, so what? So what if our species or marine turtles in specific are threatened and at the brink of extinction? So that's a question I want you all to think about for a moment, and I hope towards the end we can recap and see if you have an answer to it. Marine turtles are cohorts of dinosaurs. So they've been around since the late Jurassic, and they've shown to be existing due to their chance, skill, as well as capability. And they face ongoing threats, and because of chance, skill, and capability, they have been able to overcome them. And I'd like you to humor me for a minute and imagine yourself that you're an egg. And not just any egg, you're a leathery ping-pong ball-sized egg, just like you see in the photo in front of you, snuggled next to another 50 to 200 eggs. I would say we're about 100 to 150 here tonight. So let's imagine all of us here are eggs inside the pouch of a female turtle. Our beloved mother is holding us inside of her, and now she starts looking for a suitable beach to deposit all of us. But this beach looks and smells and feels familiar because she's directed by her internal compass to go to a beach that she has actually emerged from 20 to 30 years ago. She digs up a nest she finds suitable, deposits all of us inside, camouflages the nest, and heads back to the sea, never to return to us. She won't check if we are doing okay, if we've survived. She won't even teach us any secrets on survival from the sea. After roughly 6 weeks, 80% of us will actually make it to the surface and hatch. You, a baby turtle now, maybe smaller than the palm of your hand, squirm your way to the surface together as a group and make your way as fast as you can to the sea. Because you know that along this journey, for you to reach the sea, you will be faced with a number of threats, from pitfalls, crabs, gulls, debris, that would find you a yummy treat. And unfortunately, only 50% of you would actually make it to the sea. For those of you that actually make it to the surf, you trade one set of threats to another, as you first face the repelling force of the waves and then find a whole host of predators awaiting you. Various species of fish, dolphins, and sharks find you a yummy treat, as well as seagulls and seabirds would pick you up when you come to the surface to breathe for air. So from days to years, in the first few days of your life, you're out at the vast sea, swimming very fastly forward, basically looking for a patch of floating seaweed to settle in and protect yourself from the dangers that you were never told about. In the next couple of months, all you try to do is avoid being eaten, as well as find food for yourself to eat, and try to avoid the pressures of the challenging weather. And in this stage, 50% of you will perish. Ultimately, with the passage of years, you do grow in size. So from the size of a dinner plate in your first year to the size of a dinner table, at least in some species. And of course, with size comes some sort of protection. And the only genuine or worrisome predators at this moment are the larger species of sharks, such as bulls, tigers, and whites, and of course, the occasional killer whale, which maybe some of you have seen. We've just spotted one yesterday here in Abu Dhabi waters. At approximately 20 years of age, you are now a survivor that's in a breeding stage. And you are the one that's responsible to continue this cycle, which your very existence depends upon. And of those that began on a distant beach as eggs, only 10% of you will remain. So that was the case before human interference. So all of the threats that I've spoken about now are all natural predators and natural events that happen to turtles. But over the past several decades, human endeavors such as poaching, fishing nets, coastal development, plastic debris, chemicals, as well as dredging, has caused the survival rate of marine turtles to drop to 1%. So it is this added pressure that has caused all of the marine turtle species to either be in an endangered or a threatened state. While they have evolved to overcome all of these obstacles that we've just discussed, The most recent, which you see in front of you, have arisen so quickly and at such a scale that the species find themselves overwhelmed. So let's just recap for a minute about the odds of a turtle's survival. Let's say the mother turtle had 100 eggs. She lays the 100 eggs, 80 of them would make it to the surface or successfully develop. 40 of them would make it to the sea. 20 of them would reach adulthood. 2 of them would survive to breeding stage without any human interference. And 0.2 would make it to adulthood with human interference. So I leave you with that, and I want you to think how much more that would mean for a turtle in the face of climate change. So we have an adult now, which is actually less than an adult. We have a 0.2% of an adult. That can continue the cycle. But what does this mean with the added pressure from climate change? So the global awareness of the dangers posed by climate change has probably never been greater than today. The impact from a heating planet is now being felt around the world. Our oceans, which are the planet's most extraordinary carbon sink, absorbs the excess heat and energy released from the rising greenhouse gases that is trapped in the Earth's system. And the excessive heat and energy that warms the ocean changes temperature that leads to cascading effects such as sea level rise, warmer oceans, ocean acidification, and other effects as you see in front of you. And because the marine turtles, like we've seen, utilize both the land as well as the sea during their lifetime, the two main climate change impacts that may affect marine turtles is the rise in global temperature, thus affecting their nesting beach temperatures, as well as the rise in sea level. For the next part, I'll be focusing on the temperature part of climate change. So temperature changes could modify a marine species' metabolism and physiology. And this would lead to growth limitations, it would lead to behavioral changes, as well as impact their migration and abundance. For marine turtles specifically, they have something that's called temperature-dependent sex determination, which basically means that during embryo development, the temperature that they're exposed to determines what gender is going to be developed. And the higher the temperature, the more females will be produced. And this brings concern over whether future marine populations will face pressures due to climate change and imbalanced sex ratios. For the species that occur in Abu Dhabi, which is the hawksbill turtle, it has been determined globally that for them to have a more balanced sex ratio, they need to be exposed to 28.5 to 30 degrees Celsius with a pivotal temperature of 29.5. And that if these embryos were exposed to temperatures above 33 or 35 degrees Celsius, they will not be able to develop at all. However, the turtles here in Abu Dhabi start nesting late March to June and start hatching mid-June to August. And I don't think I'm one to tell you how hot it gets during that time. However, we have been seeing annually that the turtles are coming back. They are nesting very occasionally. The hatchlings are coming out very healthy. So what was happening? That was the question that fed into my curiosity to see what was happening to our turtles. How are they able to adapt? Are they really all female? Or have they been exposed to this temperature for a very long time that is showing some sort of adaptation mechanism? And what would this mean with the increase of temperature with climate change? So I started my research in 2019, and it continued for 3 years, where we focused mostly on determining the primary sex ratios of these hatchlings. And we achieved this through investigating temperature at nesting beaches and investigating how successful the hatchlings are, how long it takes for the embryos to develop, and then all of this fed into our main question, which was about the primary sex ratios for the 3 seasons. So the little island you see here in red is the island where I focused the research on, and it is an offshore island of Abu Dhabi. It's a private island, which is one of the 27 nesting sites in Abu Dhabi. And it hosts about 25.7% of the total nesting reported from Abu Dhabi Emirate. So from 2019 to 2020, we basically collected the regular data we usually collect, which is where are the nests located, how many eggs there are per nest, and how successful each nest was. What we also did during those 3 years was place these little yellow boxes, that's me during the summer, bearing the heat, inside these nests, just to see how the nest chamber is with regards to temperature, as well as place the similar yellow boxes at control sites in the sand to see if there's any difference between the nest chamber as well as the regular sand depth. And it's from all of this data that we collected, we were able to put it towards predicting our sex ratios. So what did the temperature loggers tell us? So our sand temperature had an average mean of 30.6 to 31.6. And as you can see, not only did it pass the pivotal or the optimum temperature, let's say, it also significantly passed both the limits of embryo development. But again, our hawksbills are still hatching successfully. When it came to investigating our nest temperature, the range was 30.7 to 32.2. And although it's a bit lower than what we've seen with the sand temperature, it still did exceed the limits of embryo development at times. So translating this to how it impacts our nests from an embryo development point of view, we saw that the nests that were exposed to higher temperatures were developing faster. So from the date of nesting to the date of hatching, that time became shorter with increase of temperature. That means the embryos are starting to develop faster with higher temperatures. When we took a closer look at hatching success against our nest temperatures, we saw that there was a significant negative trend, which means the higher the temperature of the nest, the less successful embryos are developing. And going back to sex ratio, which was again our primary question, if we assumed or disregarded the fact that only 80% would make it to the surface and assumed that all the eggs successfully hatched, it showed us that there was an 86 to 96% chance, or predicted that the hatchlings were 86 to 96% female, bringing the ratio to 6.8 to 1 female to male. So for every male turtle, there were almost 7 female turtles. And then we did correct this fact for the actual hatching success that we recorded during those 3 years. And although it decreased slightly, it was still considered very female biased, bringing the percentage to 79 to 96% and the ratio 5.5 to 1 female to male. When we did take a closer look at when the females were developing and when the males were developing, we saw that anytime after the end of April, no males were developed. So our male population is mostly being developed during the earlier months, which is when the nests are exposed to a little bit cooler temperatures. So after the mid of April, less than 20% are male. The next point, which I'll be discussing, is our research that went into the sea level rise aspect of climate change. So for our study site, not only did we have our island that we used for sex ratio, but also an additional island that we included, which is Butina Island. Some of you might have heard about it. It's one of our protected islands, and it hosts approximately 15 nests per year. The main part of our fieldwork took place in 2019, where we started flying our drones on predetermined transects to take aerial photographs of the islands, overlapping them together, stitching them together to generate this sort of model. And this model was georeferenced, so we knew the exact location of everything on the island. And in addition to that, we overlaid them with our nesting from 2015 to 2019. And this allowed us to identify where the core nesting areas are within the islands, and also extract the elevation of every nest to see what would happen with our sea level rise models. So the sea level rise models that we used were three, of 0.43 meters, 0.86 meters, and 1.81 meters for both of the islands. And what we found out first when it came to the core nesting areas is that in Island A, the core nesting was closer to the top corner here. And in the other island, it was closer to the west area in red here. But how does us knowing where the core nesting is helps us with our sea level rise models? So for the first island, when we modeled the sea level rise, we can see the core nesting areas which we've already predetermined. Although it is impacted at some level or another, even with the highest sea level rise model, we can see that not all of the nests were impacted. And when we calculated how much of our nests were going to be lost, we saw that at 0.43, we lost about 6.8 to 10.3% of our nests. At 0.86, it was 14.3 to 34.3. And at 1.81, we lost almost close to 90% of our nests in the case of the first island. At the second site, we saw the impact of the sea level rise differ by zone. And again, if we just take the part where the core nesting was, even in the highest sea level rise model, the further one at 1.81, we can see not really, there wasn't much of impact on those nests. And again, with this island, we saw 18.8 to 25.9% of nest loss, 26.3 to 34.3% loss, and 55 to almost 60% loss. So the research that we did, what did it tell us? It presented, first of all, very useful insights to this region and to Abu Dhabi itself on a species that is relatively understudied globally as well as the Gulf, especially in the area of sex ratio as well as feminization of hawksbill turtles. And although we saw that the embryos were developing successfully, we can see that there was a decreasing trend. Thus, it would help us provide management options and conservation actions to help protect these species, first of all, from dying off, and second, to maybe increase the male population a little bit. However, the question of adaptation to temperature is a question that is still in my mind, and that will I will only be able to answer it if I actually do sex ratio from this region, because the numbers that we based our sex ratio prediction on is global numbers. And some of these areas are not exposed to high temperatures like we are. So there is probably some sort of adaptation, at least I think so, in this area. With regards to our sea level rise study, we know that most of our locations in Abu Dhabi are low-lying. However, as we saw that not a lot of the core nesting areas were impacted. But this only gives us first insights to sea level rise and just gives us a push towards mapping out the rest of the areas to identify if there is any other potential areas sea turtles would migrate to start nesting, if those islands that they are directed to are lost due to sea level rise. So going back to the point that we started with, what if? So we know that a live sea turtle, and as we've seen and imagined, is full of struggles, endangered, but it's also full of wonder and beauty. From egg to adult, sea turtles are magnificent creatures, and they are a very good example of resilience and strength. So I turned to some of you which are even here in the audience, and asked you, what if sea turtles no longer existed? And some of the answers were perfect. Actually, all of them were perfect. And they really feed into the point that, yes, our ecosystem is going to be impacted. We will have an imbalanced ecosystem. our lives as humans would be impacted. So it is our job or our duty to help and conserve these species, even if it was in a very small way. Again, these magnificent creatures do play a very crucial role in our ecosystem and ocean ecology, and their absence would lead to a chain of catastrophic events, and not only to the marine life, but to us as humans. So if you imagine a hawksbill turtle usually feeds off jellyfish, and jellyfish usually feeds off fish species as well as eggs and their larvae. So if sea turtles were taken out of that equation, we'll have more jellyfish, thus less fish in the sea, thus less fish for us to eat, disrupting our economy. So that's just a very general sense of one example of what can happen if sea turtles are no longer there. With that, I'd like to thank you all for joining this evening. I'm really happy to see all of you here, and I hope I was able to give you some insight into the marine turtle world. Feel free to scan the code here. It has all my contact details if you want to reach out for any question or concern. And I really do hope that you leave today with a little bit more knowledge than you came in with. Thank you very much.
I think I can speak for the audience. That was like watching an excellent TED Talk on TV. That was just amazing.
Thank you.
And pitched perfectly for a mixed audience as well. So we'll open the floor for questions, discussion, comments. We have lots of time here. If you'd like to ask a question, we'd only ask that either we can come around with a microphone if you're stuck in the middle of an aisle, or we have a microphone on the left and right side of the room as well. So opening it up for questions.
There's a question here.
Out of curiosity, so I know very little about turtles, so I'm not sure how dumb this is going to come across. Do we have enough understanding to be able to look at creative solutions? So if we determine that we know that this is climate change has a massive effect, are we, or as science, are we looking at, for example, completely off the top of my head, creating something or an environment in these areas where we know that they're nesting to kind of fake bringing down the temperature the way we do for humans in malls or whatever? Can we replicate that? Is that something we're looking at?
That's an amazing question. Thank you very much. And yes, there are some management and conservation measures that one can take, and we've actually started it in some locations from our nesting areas, where I did not include it here, but where we have some shades of made from natural material, like palm fronds and branches and whatever, and we made the area a little bit cooler. And we did see that the time it took for the embryo to develop was much higher. So here we have about 40 to 60 days. That went up to 73, showing that there is a slower rate, but they're still developing. Plus, the hatching success was very high. So that was just a one-off experiment that we did, and it's something that we are considering for the nests that are definitely going to not hatch properly or be inundated by water. So not all the nests would have this sort of measure, but those that are susceptible to dying off are the ones that we're going to be relocating and then have some sort of shade to help in their development.
Hi, thanks for the talk. Question, if you're breeding cows, for example, you put one male bull in the field with quite a number of female cows. Do we understand what the problem actually is with the sex ratio? So if we've got all females, how many males do we need to sustain the population?
Yes, so the sex ratio that I was discussing, I kept on saying primary sex ratio, and that means the sex ratio of the hatchlings. But there is something called operational sex ratio. It's the sex ratio of adult turtles. And that has been seen in some way and in some areas to balance out with time due to marine turtles, not all of them reaching adulthood. And one male, I believe, can breed with more than one female, and that can somehow help with balancing the sex ratios.
Thanks.
Has anyone looked at the genetic consequences of that, though? Because obviously you have a very reduced fecund male population that's going to be doing most of the breeding. Is anyone looking into the genetics aspects of that?
I know some students who have, but I don't have the results on me now.
Okay. We had a question here.
So I have a little experience from our turtles in Trinidad and Tobago. So we have a fairly large population of leatherback turtles, and I've been seeing a lot of research take place on actually harnessing eggs and keeping them in an environment where it's temperature controlled, so there's a better balance of the male to female ratios. Have you all considered something like this?
Yes, I think it's similar to the question that was asked earlier, where we are taking some measures to help balance out. But again, it's not done to every nest because we do not want to mess up the population. It's only done to nests that are definitely not going to be developing.
Hi, thank you for that talk. I was at the Louvre and they have this sea turtle rehabilitation area. How does that impact what you're doing and what you're studying? And like, I wanted to know more about it. Do you know, are you familiar with that?
Yes, so the rehabilitation on turtles, generally in Abu Dhabi, is mainly done at the National Aquarium at the moment, where especially during winter, the sea turtles, because of the drop in temperature, become a little bit lazy, so they don't swim so much and then get infested with barnacles, slowing them down, making them heavy, and then they wash up to our shore. So that's when we collect these turtles, take them to the rehabilitation center, rehabilitate them, make sure they're doing okay, and then send them back once the temperature is okay. So part of the program is the holding center we have at the Louvre, where the adult turtles that are already rehabilitated, they're doing fine, they don't need the necessary care, are moved to that area as a holding area prior to their release to the water.
Hi, thanks very much for that great talk. I have a question about some of the percentages that you used at the beginning, and I was wondering how that feeds into decision-making on conservation and management measures. So if I walked in a bit late, so apologies. I saw that turtles go from a 10% survival rate to 1% due to that slide that you showed that included pollution, fishing nets, and all those things. How do you assess, based on climate change, whether an intervention, some conservation measure that you can take that targets, say, water temperature, would compare in effectiveness to other measures that tackle, say, pollution or some chemicals? How do you... I'm just interested in the process from taking the data and then deciding what to do. So if you can maybe explain the thinking behind that or what kind of considerations you take into account, that would be great. Thank you so much.
So with climate change and the two main topics that I discussed today, the temperature and the sea level rise, knowing what is possibly going to happen helps us with management decisions. So with temperature, like I just spoke to a couple of people here that I mentioned, we are moving the turtles' nests that have nested later in the season, that are very close to the shore, that will probably not develop. And then with sea level rise, we are trying to see what management actions we can take to in a way, protect the areas where these turtles may move to. So even though a turtle would come back to the same beach, if she does not find it suitable, she will be looking for other areas. We've had cases where there has been noise in some islands that they frequent, so they've moved to the one next door. So it's just a matter of conserving the areas that we know as potential sites for nesting.
Do you think there would be like a way where, so you mentioned that to get more males you need a cooler temperature. Is there a way to get like the females to breed earlier in the year?
There have been some instances around the world where they've they've seen a turtle adapt by herself. So there's nothing we personally can do to the turtle to have her nest earlier, but it's a mechanism that she should get used to. But the only issue is, even if they do adapt, it's how fast they can adapt. So with the rapid climate change impacts that we're seeing, will the turtles be able to adapt as fast as they have before, or move north, or move to cooler areas, is the question that we don't have an answer yet for.
Thank you.
So I took a big interest on the yellow pouches that you put in the nesting holes. What exactly are they?
So they're temperature data loggers. So they're basically a device that records the temperature for us. And we can set if we want to take it every 15 minutes, every hour, every day. And then over time, we can see what the nest temperature was during the nesting period.
Thank you.
Back.
السلام عليكم.
وعليكم السلام.
شكرا أستاذ هند على the nice talk. Are the heat-related challenges of life for sea turtles limited to the nesting period only? Is it possible to make shade platforms, or they are useless for the turtles? Because I noticed different sea creatures gathering under the oil platform in the sea.
So with temperature, it's mostly on nesting beaches because it will impact the sex ratio. I was unsure about the second question. I didn't. If you can repeat the second question, please.
To build like a shaded platform in the sea, because I notice creatures and fishes gathered under the oil platforms.
Yes.
Yeah.
I think because as well as oil platforms are a good feeding spot for them, because there's a lot of fish over there. I definitely don't know of any research that has been put into creating shade in the sea, but I know of on land. So it's a question I don't have an answer to, unfortunately.
We'll take two more questions, one in the back here.
Good evening. I would like to ask a question. How does microplastic affect sea turtles?
So with sea turtles, plastics in general, rather than microplastics, they would eat them. And there have been a few cases where we've seen plastic pieces inside the gut of marine turtles, and we've also seen balloons, we've seen plastic cups. So it's not just the microplastics that would affect them, it's also the bigger macroplastics, let's say.
Thank you so much.
No problem.
Thank you for the talk. And I have a question regarding the temperature. It goes on the same note as the gentleman. You just investigate the temperature during the nesting,
Yes.
but there is a lot of ecological studies, probably not, I'm not familiar with turtles, but probably it can apply also. They suggest that the female, sorry, the mother, if she's exposed to different temperature before nesting, she can invest differently in whether in sex ratio or in the quality of egg laid, and then that would affect also the sex ratio, the hatching rate, and so on. So do you think it's feasible in turtles, or did you ever try to see what is happening before laying and before hatching?
So with sex ratio itself, it's not the temperature when the eggs are inside the turtle. It will only be when the eggs have been deposited, and that's when the sex of the embryos would be determined. It's in the nest, so it's not genetic like other species. It's within the nest, and the temperature will impact it. There haven't been any studies here on pre-nesting. There has been on nesting and post-nesting only.
Okay, thank you.
And we'll take one last question here.
This is a general question. We're all of us here are obviously very interested. So what can the society or the community do when, we do find on the beaches, especially in Saadiyat area, beached turtles that with barnacles or that have just been hit by a boat or by many different reasons. So what can people do when they find that? Do they contact the environmental agency? Is there a toll-free number? And can people volunteer to help in any programs concerning the turtles?
Yes, so with the hotline for reporting dead, live, even sightings of any marine species, even terrestrial species, is 800-555, which is the Abu Dhabi government hotline number. And then they would direct it to us to come out and investigate whatever the case is. With regards to volunteering program, unfortunately, as of yet, we haven't set up any volunteering programs. There is one on Saadiyat Island, and that's a community effort. They themselves wanted to help, and they themselves brought together the community and the residents, where they started patrolling the beach to see and to report any tracks of turtles.
Hind, myself, and I think the audience would like to extend a great thanks for this amazing talk. Extremely interesting. I know there's... I know there's many more questions that people had, and what I'd suggest is come down and talk to Hind, but try and keep your questions relatively short so we can cycle through them. There's also canapes, drinks, refreshments outside, so feel free to carry on the conversation with others about this amazing topic. You know, climate change does represent an existential threat to marine ecosystems and the organisms in them. And it is our part as a member of society to try and think about issues like this and what we as individuals can do to try and help organisms like these amazing hawksbill turtles that we learned about tonight. Again, thank you very much.
Thank you very much.